This is one of a series of mathematics revision lectures given by the Further Maths Support Programme. In this lecture we're looking at Edexcel Mechanics 1 and the topic is Newton's laws of motion. The specification for Newton's laws is as follows. You have to apply Newton's laws of motion or be able to apply Newton's laws of motion rather in up to 2 dimensions, so maybe sometimes in vector form using AI and BJ. Quite often these will be in the context of bearings, so I may well be in an easterly direction and J in a northerly direction. The problems may involve connected particles, so moving in a straight line under gravity. So for example, this may be an object in a lift where the objects are connected by virtue of the contact of one with the other on the lift floor. They may involve pulleys or may involve things such as a car pulling a caravan. The questions may be set on an inclined plane, which could be smooth, or may also involve frictional forces. So you do also need to have an understanding of the frictional forces, coefficient of friction, and F equals mu r. Newton's second law is the one which is mainly going to be used. So we've got that the force is proportional to the rate of change of momentum, but in this context we're simplifying that to the equation F equals ma. So for Newton's second law of motion we can use the equation F equals ma and quote it as such. A little bit more about the frictional force. In general, the frictional force is going to increase if we've got a static situation up to a maximum, so it's a linear increase, a straight line, increasing up to its maximum, after which if we need or we try to push any harder on an object, the frictional force can't increase anymore, and so we say that for its limiting value of friction it's equal to mu times r, where mu is a coefficient which is dependent on the surfaces. So you will either be given that coefficient of friction for the 2 surfaces or expected to find it in the question. Okay, to illustrate those points, 1 or 2 exam questions now. So this is a question from the January 2010 paper. And reading through the question first of all, it said a particle of mass 0.8 kilograms held in rest on a rough plane. The plane is inclined at 30 degrees to the horizontal. The particle released from rest and slides down the plane, and it moves 2.7 meters during the first 3 seconds of its motion. So we're asked to find firstly the acceleration of the particle, and having done that, find the coefficient of friction between the particle and the plane. Well, the first part of the question actually doesn't involve Newton's laws at all. It's an equations of motion, so Thuvant equations, where we're told that S is equal to 2.7. The initial velocity is 0, and we're told that t is equal to 3 seconds, and we need to find a. So that is a situation where we'll use the equation S equal ut plus 1/2 at squared. And substituting the values we know into that, 2.7 is equal to 1/2 a multiplied by 3 squared, which of course is 9. If you rearrange that and solve, a is 0.6 meters per second squared. Now in the second part of the question we've got to find the coefficient of friction between the particle and the plane. This will involve then looking at the forces that are acting and using Newton's second law, F equals ma. Well, here's a diagram to illustrate the situation that we have. The angle of the slope is 30 degrees. The mass is 0.8, so the weight of the object 0.8 g newtons. The normal reaction acting perpendicular to the plane, let's call it r. And because the object is moving down the plane with an acceleration, the frictional force must be such to oppose that, so it will be up the plane, and of course it's equal to mu r. So if we now resolve the forces, firstly perpendicular to the plane, which we can just illustrate with a little diagram like that, then we have that r minus 0.8 g cosine of 30 degrees, that must be equal to 0. The cosine 30 degrees comes from the fact that the angle here is 30 degrees, and we want the adjacent side, if you like, of this little right angle triangle I've just drawn in there. So 0.8 g cos 30. Therefore r is itself equal to 0.8 g cosine 30 degrees. We know that F is equal to mu r, and mu is the thing that we're trying to find. So we can use that, but resolving the forces down the plane. So now this time we're going to resolve down the plane and use the fact that the force down the plane F is equal to ma. That's F equals ma, so not the same as the frictional force. That's the total force down the plane is equal to mass times acceleration. So acting down the plane, we've got the weight, or at least the component of the weight, 0.8 g sine 30 degrees this time. That's down the plane. Up the plane is F, which is mu r, so mu multiplied by r that we've found as 0.8 g cosine 30 degrees, and that must be equal to the mass 0.8 multiplied by the acceleration that we found in the first part of the question, 0.6. Now we've got to find mu from that, so rearranging the equation, mu will be equal to the 0.8 g sine 30 minus the 0.8 times 0.6. Now notice 0.8 cancels out, so to make life simpler for ourselves, let's do that. Cancels out from each side of this equation or through every single term, so that we've got g sine 30 minus 0.6, and we're going to divide that by g cosine 30. And if you calculate that to two significant figures, we get 0.51. Right, let's look at how the marks were allocated in that question. 3 marks in the first part of the question. The first 2 marks for using the equation s equals ut plus half at squared, so m1 and a1 for getting the equation correct with the correct substituted values, and then another accuracy mark for getting the correct answer, 0.6. In the second part of the question, 5 marks available. There's a B mark for getting the value of R here. So that's just a known method required just to get that R is 0.8 G cos 30. There's another B mark for using F equals mu R. So I beg your pardon, the B mark is up here for using F equals mu R and getting the correct value. The M1A1 for using the resolving down the plane, and then finally an accuracy mark at the end for getting the 0.51. So 5 marks in total for the second part of the question. The next question is one of connected particles over a pulley. So just reading through the question first of all, we've got two particles A and B with masses 5m and km, and we're told that k is less than 5. The particles connected by the light inextensible string which passes over a smooth light fixed pulley. There are standard statements in this sort of question. The system is held at rest with the string taut and the hanging parts of the string vertical, and A and B at the same height, as shown in the figure 4. So it's worth reading through the question, although the diagram shows everything that we need to know in this particular case. The system is released from rest and A descends with an acceleration of 1/4 g. So let's just mark that in on the diagram. We've got an acceleration here equal to 1/4 g. Show that the tension in the string as A descends is 15/4 mg. So we've got a tension in the string acting up on A, and of course also transmitted through there acting up on B. The weights are 5 mg for A and kmg for B. Now this is quite unusual in this question where we're actually told the acceleration, so this is not one of those where we need to do simultaneous equations. We can simply look at F equals ma for particle A. So for A, using F equals ma, we can say that 5 mg minus t is equal to its mass, which is 5m, multiplied by the acceleration, 1/4 g. And rearranging that, t is equal to 5 mg minus 5 mg over 4, and that is then, well, 5 mg is 20 mg over 4, so in total we've got 15 mg over 4. So that's what we've been asked to show in the first part of the question. In the second part of the question, we've been asked to find the value of k so that we can use F equals ma for B and look at the forces acting on B. This time we've got a force downwards kmg and a force upwards equal to T, and of course we have that the acceleration is upwards, so let's put T minus kmg, and then that will give us our acceleration equal to 1/4 g upwards. So we have then mass, which is km multiplied by 1/4 g. T, if we rearrange that, becomes 5/4 kmg kmg. But of course that tension is transmitted through the cable that's joining the two, so it's equal to the 15 mg over 4. So now we have that, therefore 15 mg over 4 is equal to 5 over 4 kmg, and you'll see that most things cancel out, the mg's go, and so we've got k is equal to 15 over 4, which is equal to 3. So k is equal to 3, and that's the end of that part of the question. The final part of the question simply says, state how you've used the information that the pulley is smooth. The pulley is smooth allows us to say that the tension is the same for both particles. So the tension is transmitted through the string because it's a smooth pulley. Right, looking at the mark allocation here, in the first part of the question, there's a method mark and an accuracy mark for simply getting the equation correct for F equals ma for particle A, and then an accuracy mark as long as your working is correct. Now notice that of course you were given the answer there, so this is very dependent on correct working to get that A mark. In the second part of the equation, a similar M1 A1 for the statement of F equals ma for particle B, and then an A1 mark at the end for k equal to 3. And finally there was a B1 mark for stating that we could use the tensions as being the same because the pulley was smooth. The final question comes from June 2011 paper, this time again connected particles over a pulley but including an inclined plane. So looking through the question, we're told that the masses are 0.3 and m, so we need to calculate the value of m for one of these particles. The particles are attached to ends of a light inextensible string over a smooth pulley. We're told that the plane is rough and that the angle is alpha. Well, it actually says the tan alpha is equal to 3/4. So we're told the tangent of alpha. The coefficient of friction is 1/2. So putting some of that information onto the diagram first of all, the idea that tan alpha is equal to 3/4 means that we don't have to really calculate the angle when we need sine and cosine. So for the reason for giving that is if you draw yourself a little diagram, we can see that we have a 3, 4, 5 triangle, or using Pythagoras' theorem. Therefore sine alpha is 3/5 and cosine alpha is 4/5, which are going to be useful. Also we're told that mu is equal to 1/2. So just it's worth putting the information from the question onto the diagram. Putting some other information on there, we don't know the value of mass for Q, so we can write in here that the force downwards is m times g. Then for P, we know its mass is 0.3, so the force is 0.3 g, and there will be a normal reaction, and then a tension in the cable which is transmitted through the cable because we've got a smooth pulley. We've also got a frictional force, but we don't know which direction things are moving in at the moment, so we'll have to read on the question to see if we can put that in. So the next part says that the system is released from rest and Q accelerates vertically downwards. So there we are. Q is going to accelerate down here with an acceleration of 1.4 meters per second squared. that allows us, of course, to say, right, if it's accelerating downwards, P is going to go up the plane so that the frictional force on P is going to be acting down the plane. Having done all of that, we were asked to find the magnitude of the normal reaction of the inclined plane on P and the value of M. The first part then is looking for the value of R, the normal reaction on P. So that's a case of resolving perpendicular to the plane. So resolve, if we draw a little diagram again, in this direction perpendicular to the plane, we can see that 0.3 g cosine alpha is equal to R. And because we know that cosine alpha is 4/5, then this gives us R is equal to 0.24 g. You can leave it as like that, or if you wish to give it as a decimal, then it comes out to be 2.35 newtons. So R is 0.24 g newtons. For the second part of the question, then we need to find the value of M. This is going to be a case of using F equals ma, Newton's second law. So we could write down a single equation for the combined system. That would eliminate T from our equation. However, I think it's probably easier to do two separate equations, one for Q and one for P. So we're going to use F equals ma firstly for Q. And if we do that, we can see that mg minus T is equal to its mass m multiplied by the acceleration 1.4, so we get 1.4 m. And if we calculate that, g is 9.8, so T is 9.8 minus 1.4, or 8.4 m. Doing a similar thing for P, then we're looking up the plane this time, so we've got T acting up the plane, we've got F acting down the plane, and the component of the weight 0.3 g sine alpha also acting down the plane. So that's the combined forces, T minus F minus the component of the weight. That will be equal to the mass multiplied by the acceleration, this time 0.3 multiplied by the acceleration 1.4. Now we know that F is equal to mu r, and mu is equal to 1/2, so therefore that's equal to 0.12 g. We've calculated in the first part of the question that T is 8.4 m, so substituting those into the equation for P, we have that 8.4 m minus F, which is 0.12 g, minus 0.3 g sine alpha. Sine alpha is 3/5, 0.6, so that gives you a total of 0.18 g. And that's equal to 0.3 multiplied by 1.4, or 0.42. Now all we need to do is to make m subject of that equation. So therefore m is equal to the 0.42, 0.12 g and 0.18 g, that's a total of 0.3 g, so plus 0.3 g, and dividing that by 8.4. And that comes out to be 0.4 kilograms. So M is equal to 0.4. Alright, finally looking at the mark allocation for that question. The first part of the question, there's simply an M1 and A1 for the resolving and getting a value of R of 0.24 g. The second part of the equation, the use of F equals MA for Q was a method and accuracy mark. The accuracy mark actually is obtained at this point here, as soon as you've used the equation correctly. A method mark for using the equation F equals MA for P, and 2 accuracy marks applied there. You would either get 0, 1 or 2 depending on how correct your equation was. There's a method mark for using F equals mu R, and then dependent on that all being correct, there's a method mark for substituting the values you know and eliminating t from that equation, and a final A mark for getting the value of M equal to 0.4. Well, that completes this revision lecture. There are further revision lectures available, and also more information can be found on the website for the furthermaths.org.uk.